All right, we are back. So, the purpose of this lecture is to move on to develop some of the maybe a little bit more abstract properties of trig functions. I won't worry about computing anything on the nose for a little bit. I'll just settle for the question, is this trig function positive or is it negative? So let's try to work that out. And we'll work it out in the particular example of an angle of 2 pi over 3. So here's how we'll think about it. So let's do that. So let's draw a unit circle. And in order to compute trig functions at an angle of pi over 3, we'll follow the instructions that are trig functions. Start at the point 1, 0. Now rotate counterclockwise by an angle of, I want to think about 2 pi over 3, so we'll go 2 pi over 3. And in order to figure out whether the resulting point will have positive or negative x, y values, let's figure out how big that angle is. Let's try to draw it correctly. And let's try to compare it with this angle, a right angle. A right angle being an angle of pi over 2. So let's ask ourselves, which is bigger? Two pi over 3. And maybe I'll use this sort of not terribly standard notation. I'll ask if 2 pi over 3 is bigger than or less than pi over 2. And, well, there are a few ways to think about that. If I want to, let's imagine I wanted to solve that inequality. It's not really solving because there's no unknown. Let's figure out if that inequality is true or false, I suppose, is what I'm saying. So here's one mindset, clear denominators. So I guess that means I'll multiply this 2 to the other side. I'll multiply that 3 over to the other side. And I'll wind up with the question, is 4 pi greater than, question mark, 3 pi? And the answer, of course, is yes. So the answer to this is yes. This is the bigger one. So 2 pi over 3 is bigger than pi over 2. So if I want to draw an angle of 2 pi over 3, I would go past pi over 2. Well, all the way over here, I see an angle of pi. An angle of pi is half of a full revolution. So there's what I would get if I rotated by an angle of pi. Well, which is bigger, 2/3 of pi or pi? Well, of course, pi is bigger. So 2/3 doesn't quite make it to an angle of pi. So an angle of 2 pi over 3 will put us somewhere in this range. All right, so with that out of the way, let's now actually read the question. So from the point 1, 0, start of a sentence should be capitalized. Rotate by an angle of 2 pi over 3, as we just did. What quadrant do we land in? Well, that looks like it's quadrant 2. So now we'll ask ourselves, is the trig function, our trig function value of 2 pi over 3 positive or negative? Let's start with cosine. So cosine of 2 pi over 3 is exactly the x coordinate. In this quadrant, in quadrant 2, this quadrant, is the x coordinate positive or negative? It's negative. What about sine? Well, sine is the y coordinate. Is the y coordinate of this point positive or negative? Well, it's above the x-axis, so it's going to be positive. Tangent of 2 pi over 3, remember tangent is y over x, so that will be a positive number divided by a negative number. That's negative. Secant is 1 divided by the x coordinate. That's 1 divided by a negative is negative. Cosecant is 1 over y. That's 1 divided by a positive is positive. And I guess for no good reason cotangent doesn't appear, let's ask the same question for cotangent. Cotangent of 2 pi over 3. Cotangent is x over y. So x is negative, so it's a negative divided by a positive. That is negative. So you can run this argument for absolutely any angle. You just need to figure out which multiple of pi over 2 the angle in question lives between, because that'll tell you, when you draw the angle, which of the cardinal directions you pass through. So let's do that. Let's fill in a table encoding that. Maybe we'll fill out that table by drawing a picture. So there's a unit circle that is an absolutely perfectly drawn circle. I won't have anyone tell me otherwise. There's an angle of 0, an angle of pi over 2, an angle of pi, an angle of 3 pi over 2. Back to 0, we have an angle of 2 pi. So it looks like all of the angles between pi over 2 and 0, all of these angles will result in points in quadrant 1. So if you happen to be, but if the angle in question is somewhere between 0 and pi over 2, rotation by that angle puts you in quadrant 1. In quadrant 1, cosine is positive, sine is positive. Tangent is sine over cosine, is positive over positive is positive. Secant is 1 over cosine, positive. Everything's positive. In between an angle of pi over 2 and an angle of pi, well, there's pi over 2, there's pi. All of those angles live in quadrant 2. In quadrant 2, cosine is the x-coordinate, is negative. Sine is the y-coordinate, is positive. Tangent is y over x, is negative. Secant is 1 over x, is negative. Cosecant is 1 over y, is positive. Cotangent is x over y, is negative. The next bit of the unit circle that we see is the set of angles between pi and 3 pi over 2. So there's an angle of pi. There's an angle of 3 pi over 2. It looks like all of the angles between these two live in quadrant 3. So everything here will live in quadrant 3. Cosine, remember, is the x-coordinate. Sine is the y-coordinate. X-coordinate looks like it's negative. Y-coordinate in quadrant 3, negative. Tangent is y over x. So that'll be tangent is y over x. So that will be a negative divided by a negative, is positive. Secant is 1 over x. That'll be 1 over a negative, is negative. Cosecant is 1 over y, will be 1 over a negative, is negative. Cotangent will be x over y. That'll be a negative divided by a negative, is positive. The next interval in question is 3 pi over 2 onto 2 pi. So switch colors again. 3 pi over 2 onto 2 pi lives in quadrant 4. In quadrant 4, the x value is positive. So cosine is positive, y is negative. Sine is negative, because sine is y. Tangent is y over x, will be negative over positive. Secant is 1 over x, will be 1 over a positive. Cosecant is 1 over y, will be 1 over a negative. Cotangent is cotangent is x over y, is positive divided by negative, is positive. And you could keep going forever, right? This is an angle of 2 pi. I could get over here by going all the way around this. So if I go all the way around the circle, a total of 2 pi, and then an extra pi over 2, that's a total of 5 pi over 2 radians. So an angle of 5 pi over 2 radians would also put me here. would put me there. So all of here is the set of angles between 2 pi and 5 pi over 2. So angles between 2 pi and 5 pi over 2 also live in quadrant 1. And so I'm copying down the quadrant 1 column to the far left. Everything is positive. Cool. So let's use this idea to make some computations. So cosine of 4 is an irrational number. But let's try to figure out cosine of 4, is it positive, is it negative? That's all I'm going to try to figure out. Well, to do this, ask yourself. I want a total of 4 radians. Is 4 between 0 and pi over 2? Well, pi is somewhere around 3. So is 4 somewhere between 0 and 3 over 2? No, it's not. So this is certainly not something that you would write in your own write-up, but here's the logic. 4 is not between 0 and pi over 2, because pi over 2 is somewhere around 1.5. So definitely not the first column. Is 4 between pi over 2 and pi? Also no, because pi is somewhere around 3. 4 is not between 1.5-ish and 3-ish. All right, let's see if it fits into the third category. So let's see, pi over 2. No, there's no pi over 2 anymore. That's not what I'm interested in. So I want to know if pi is somewhere between pi, which is approximately equal to 3, and 3 pi over 2. So pi is 3-ish, so the top is 9-ish, divided by 2 is 4.5-ish. Is 4 between a number that's close to 3 and a number that's close to 4.5? Yeah. 4 is between 3 and 3 pi over 2. So if I want to understand if cosine of 4 is positive or negative, I should look at this column, because 4 satisfies that inequality. So apparently this angle is in quadrant 3. I want cosine. Cosine is negative. So cosine of pi over 4 is negative. Let's play that same game again, but maybe we'll play it by just saying words instead of writing them. 0.2. So tell me, is 0.2 between 0 and 1.5? Yeah, sure is. So this angle of 0.2 an angle of 0.2 is in quadrant 1. In quadrant 1, tangent is positive. Cosecant of 7. So let's play the same game. And we'll play it saying words out loud without writing. Is 7 between 0 and pi over 2? No, it's not. 7 is like 7. Pi over 2 is 1.5. 7 is too big. 7 is not less than pi, because pi is like 3 and some change. 3 pi over 2, that's 4.5-ish. 2 pi is like 6-ish. 2 pi is 6-ish. 5 pi over 2, that's 5 times something that's 3. So 5 times 3 is 15, divided by 2 is 15 over 2. Yeah, that's 7.5. So apparently 7 is between 2 pi and 5 pi over 2. That puts me in quadrant 1. In quadrant 1, cosecant, I want cosecant, is positive. Neat. And here's something that you can do on your own time. Pull up a computing machine, compute exactly those things, see if this agrees.